Hello everyone, welcome back to another series on the power of R coding tutorials. This is the Urban Maker Craft, and today we'll be going over the use of the dpylr library. So what the heck does dpylr stand for? I have no clue. I think it could mean, it could be an acronym or a pseudo acronym for dplyr, because that's what's shown on the logo, but I honestly have no clue and I don't really want to find out either. So before we get distracted, let's just jump in. So we open our RStudio over here and we are greeted with our friendly console. If we see anything over here, that's fine. And at this point, I would like to go over some very practical things. So in the previous video, we've been doing a lot of slides. I think that's fine for instance, learning technique and theory and all that stuff. But we do need to be able to do actual design with, actual programming with getting your keys on the keyboard. So I think it's best that I do the rest of these videos with literally just me talking off the cuff, trying not to make a fool of myself on camera. And so it just will be the start of the following videos, and I hope you guys enjoy it. So when we come over to the top here, we see there's a bunch of stuff. So it's a very typical kind of control panel, or something like Word or Excel, stuff like that. Over here we see our very familiar file icon. Clicking on it, we are given some options. So very simply, I think the names are pretty self-explanatory. We manage our files over here. So over here we want to go over to new file. We want to click R script. So what exactly is R script? Well, it's something like a sketch in Arduino or a Python. I think it's also called a Python script, not too sure about that. Or basically just a place where you can work on code. Well, don't get me wrong, you can actually put code into the console. That's we've been doing that for the entire of this series, but it doesn't really work if you are writing long or kind of arduous lines of code, because then you won't be able to make edits. Once you mess it up, you have to copy and paste. You can't run multiple code lines. You can't really see the effects. It's kind of like a drip and drab system where you're basically just giving instructions one by one, and that's kind of not what we should aim for, because when we write code, we kind of want to be able to write long code that has structure and form, and that's the whole point of using a script. So over here we have created a new script. We can save it now by just pressing Ctrl S, or going over to the file over here, save. Very typical like Word or text processor type of stuff. But we won't do that now because we're not going to write that much code. We're just going to do some basics. So over here, we are basically pretty much set. So today's video, as I mentioned before we got kind of distracted, will be on the use of the library known as dplyr, which is a data wrangling library. It is an add-on. It doesn't come pre-installed with R. You must install it. And it does open a lot of opportunities. It creates a lot of alternative ways to do things, and we're just going to explore some of the ways, discuss what differences it has with base R, which is, by the way, is R which does not have all these bells and jingles, and we're just going to discuss and show you guys how to do some stuff with them. So before we do anything, we have to install the library. So the way to install libraries is kind of like import in Python, but in this case we will go to install.packages, and we will just type in dplyr, I hope I spelled that right, into the argument, and we will put quotation marks just because I think it's just good practice. If I don't put it, let's see what happens. Boom. Yeah, there was some issue, so we must put dpylr. Yeah, we must put this quotation marks because that's the way it references it. And if it asks you to restart blah 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 blah, there's been some, I mean, honestly, I think restarting is fine, but I think on my computer restarting doesn't work. There we go, it just did the same thing over again. So I just say no. Yeah, it's update, stuff like that. In your case, you will probably have to install it from scratch, so it might take longer. In this case, I think I tried to install it again, and I don't know what I did to it. Alright, whatever. Alright, who cares? But in your case, it should take a bit longer. You will see some messages which say that it's installed successfully, etc, etc. And once that happens, we are basically set. So we have installed the library, and we can now begin to use it. So before we use the library, however, we need to kind of tell the code that we're actually going to use it. Something like what's the word? What's it called? Oh no, I've forgotten so much. Oh my goodness, it's not in Arduino. Okay, never mind, I've forgotten it. It's something like in Arduino, when you have to basically call the library at the start, and then you kind of have to reference it. So I think it was. Alright, this is really detracting, but just for the sake of me not making a fool of myself on camera, actually I've already done so, but maybe we can jog my memory a bit. For the life of me, I cannot remember what's going on. Include. So it's something like the include library thing in Arduino, where you include a library that we use. And why is this font so tiny? Whatever. Yeah, that's not part of this. Is not an Arduino tutorial. This is our tutorial. So sorry for the distraction. It's something like include. So when we want to use a library, we have to type in library open parentheses, and then we just type in the same thing. And I don't think we need the. No, we actually don't need the parentheses. So yeah, we just type that in. The line separator isn't necessary, and we click run. We see that it attaches the packages, blah blah blah, everything's fine. So we only have to do this once before we start our work, but it never hurts to do this, put this right at the start of your code, because after all, you don't really know if you'll be running it on a new on a fresh session, so it really just doesn't hurt at all. So doing this just tells yourself that tells the computer, tells yourself that you're going to be using this library, and then from then on you can use all the functions. So let's literally get started. So the first thing I'll introduce is something called the pipe operator. And alright, since we are basically at some very practical skills, let's talk about how to write comments. So comments can be written with a pound sign or the hash sign, and this, so it's basically just syntax. So comment can be inserted like this. Alright, so let's just start with the most useful, which in my opinion, element of the dpylr package, and that is the pipe operator. So what exactly does it look like? So pipe operator looks something like this. It is not really pipe looking, but you can kind of guess what it does from its form. So you have this percentage sign here, you have a inequality sign, and then you have a percentage sign again. So this is basically our version of what a pipe should look like. Whether or not you agree with that interpretation, that's entirely up to you. But what this does is that it allows you to basically truncate your functions such that you can make a long chain of functions and not have to essentially evaluate a function one by one. So let's just say let's just give an example. So the pipe operator, for instance, if let's say I would like to perform operation on data. So let's say I let data equals to data. So remember that we must always ensure that we map our new variable onto our old variable so that we update it. If not, it would mainly just print it, and it will not save it to its memory location in the computer. That's just something that we must bear in mind, not just for R but for most languages. So instead of, usually if we don't have the pipe operator, so without the pipe operator, we would basically be doing something along the lines of this. So it would be function, and it would be data. Okay, sorry, we need to put data equals to function 1, and then we do data, and then we do it again, and then we just repeat, rinse and repeat until we are done. And that is kind of cumbersome, because imagine if you have to write this, all over again. That doesn't really seem very, and also it's kind of difficult to see the flow, because you kind of have to follow it vertically rather than horizontally. It doesn't really look very nice. It isn't a lot of fun. It's just something that is pretty inefficient. So what the pipe operator does, it says, alright, you want a way to basically take the output of one function and dump it in as arguments of another. Alright, sure. So now what we do is that we use the pipe operator, and that means we take data equals to data, and then we pipe it into the first function. We pipe it, and we realize that now the argument for this function is blank, because with the pipe operator inserts the argument as our it takes the data that we put into the pipe function and dumps it into the argument of our function, which is being piped to. So that is pretty neat, because now we just can literally go full steam on dumping stuff into our recursive chain of functions, and then we can blah 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 blah, and then finally we are done. So that is something that's pretty useful because you can see how much faster it is to write out this entire sequence of code rather than having to use constantly redeclare the variable without using the pipe function. So that's something that is pretty darn useful. So let's just do an example here to check what we've learned. So let's just create a function, and if my memory is not messed up, I should be able to do this. So function, let's just call the argument x. Well, we've done this, the out of code should have covered some of these techniques, and it's pretty simple. If you don't really, you can basically just get the idea. So it is a name of function, basically the variable. Okay, not really a variable, but name of the function. And then we have the function, which is creating a function. And then we basically do, we have an open square brackets, curly brackets, close curly brackets, and our function comes here. So we will return, let's just say we return 2 times x. So that's something that we want to do. So we return this. Now let's just check everything's working. Alright, everything's fine. Okay, so to run individual lines of code, we press run, and we see that the cursor kind of bounces down the lines. And in order to run everything, we just click this, and it just runs everything. So it runs the entire document. So we see that our function has been well defined because it's simple function. Not much could have gone wrong. So that's what happens. And now let's try 2 methods. So let's say we have x. Okay, we're not call it x, let's call it number, or like y, fine, equals to 1. I keep forgetting that I don't need the line separator. So using no pipe operator, we would have to do something like this. So we would have to say y becomes my function, and we pass the argument of itself in because we want, we only have one variable. That's what we want to do. We want to double the value of y. Oh yeah, and if you're kind of confused why this is y and this becomes x, then please check out the out of code video where we kind of discuss what exactly function notation is and why you can do this. So alright, so this is using no pipe operator, and then we just want to print y. Or actually, I think yeah, we need to print it. If not, it won't be it won't be a display onto the console. So let's just go. Alright, 2, perfect. Well, this was kind of easy. I mean, it was only one variable and one function, so pretty darn easy. So okay. So let's say if we are using the pipe operator. Well, let's just say it kind of makes our life easier, somewhat. So y is y, and then we use the pipe operator, and we say my function, and we don't put the very important thing is we do not put an argument into my function anymore, because y is going to be piped into the function. It will take the position of the first, it will take the position of, well, there's only one argument, so it just take the position of the, of whatever argument that is. So that's basically, that's basically the whole gist of it. So we pipe this in, and then we have it come out here. So that's, well, so let's just print y again. Okay, we can get rid of this. We can then run this code, and there we go. It's the same. It's exactly the same as we left it. Alright, so a very natural question would be, what happens if the function takes 2 values of 2 arguments? So which one would it pipe to? And the answer is, technically, I have not really tried, because firstly, usually in R we don't technically like to store things as 2 separate variables. We store it as a vector if it's more than 1, and then we basically reference a vector. So it is not very common to see 2 functions. I mean, if you it's not very common to see a self-defined function which accepts 2 variables, because usually you would simply just define a vector to go into the function as 1 variable, because a vector is, well, after all, 1 variable. Yeah, but let's just say we for some reason wanted to do this. I actually have no clue what's going to happen. So let's go. So let's just say y becomes y, and then we pipe it into this function, and let's literally see which one it goes into. So we have x times y. We've piped in y. Let's just double check. Alright, let's call it z for clarity. So z comes this, and let's see what happens. So it passes it into the first function, Okay, so let's just say we put 2 or put 1, so 1 times 1 should be 1. There we go. So after I pass it into the first function, so sorry, the first argument, so that's something to be mindful of. The pipe operator will always pass the value of the whatever is passed to the pipe operator into the first argument of a function. Well, that's pretty much ties in with what I'll be discussing later on using the pipe operator with some actual dplyr functions. But just bear in mind, if you want to use a pipe operator, it only will pipe one argument. So if let's say you wanted to be more not have it so clunky, we could actually say let z be a vector of length 2, and we have our 2 values here, so 1 and 2, and our function essentially we can say let it just dump in 1 value, and we return once again this is remember that R is not 0 index, so 1 is the first index. This is unlike Python and C++, just something to be aware of. So we could do this, and then we could simply just run it. So there we go. Pretty much solves our problem. We don't have to worry about we don't have to worry about having two two arguments. We pass one argument, but it is a vector with 2 values, and we get the same result. And that's something which basically is pretty important to remember in R, is that we don't want to pass unnecessary arguments when we can consolidate our variables into vectors. So now that we've done pretty trivial examples, let's go on something more interesting. So we're going to look at some functions in dplyr. The first, of course, let's kind of do a bit of recap. So recap, in the previous lesson we learned about using Boolean indexing and standard indexing. So we learned about indexing, which is, if we don't recall, it is data, and then we have x and y, stuff like that. And we also learned about Boolean indexing, which is kind of an extension of normal indexing, and that is to basically supply say column or row. This has to be column, and then we supply this is logical or arithmetic or comparison operator, and then we say condition, and then row condition. Well, actually, by right, very strictly speaking, there should be data column, data $sign row. Once again, if you have any doubt on what we're doing, you can always go back to the previous videos and have a look. So this essentially basically limits the selection of data to a set where the column either the column values meets this condition or the row values meet this condition, or if you define both, then essentially you technically simply choose, you basically choose columns and rows when you apply like a union filter, something along those lines. I don't think it's that useful in the sense that you wouldn't need to specify the data to such a degree, but maybe that would be useful. We'll see. So this is what we have done, and let's just do an example. So over here, let's create a data frame. Once again, we've also did our data types in the previous video. Let's just say let's just create a data frame, and once again you can just copy this down, because I really don't see the point of memorizing all this, because you can just use copying down when you need them. And let's just say, okay, I think this should be pretty correct. Okay, let me just run it in my console first to check that it's correct. There we go. Aha, so we've created a random data frame of data that's okay. Maybe let's make this more dicey, more fun. So there we go. We created a random data frame with something happened. What the? Oh, I know what happened. I'm silly. Yeah, I think Okay, I know exactly what happened. So sample 10, because that would, if I'm not wrong, I should be able to. Okay, there we go. So I kind of forgot my syntax a bit. So replacing this with. Okay, so sample and sequence, I'll probably do a video on that separately because that really isn't part of dpylr. It kind of exists. I'm not sure if this. I'm not sure so much about sample. I'm pretty sure sequence exists without dplyr. I will double check with that and we'll see. And I don't think, yeah, you can refer to documentation how to use these functions. Even up to this day, I don't really remember the exact methods of these functions like by heart. I kind of sometimes have to use what I did just now, going over and then just typing it in and then to see what the argument structure is and then guessing what on earth that could mean. It's something a bit of like hit and miss in that sense. So if you're interested, I can do a video on that separately perhaps, or I could simply just link the documentation page and you could pretty much figure out what it does on your own. So I've just created a data frame with a sequence of 1 to 10 and a random sample of data from the vector 1 to 100, which essentially means values of 1 to 100, and I want to choose 10 of them. So that's what I'll do, and I will now, okay, let's just run this thing and check that everything's alright. Alright, so this seems pretty legit. Okay, so what now we'll do is, okay, we can use these comment headers. Without using the pipe operator, excuse me, let's say we want to select values that are divisible by 2. This is something that's pretty common. You might even need it for a project. Well, this is a recap because we've done it previously. In order to do this without using the dpylr functions, we would essentially go something like this. So okay, I'm not going to save it, I'm just going to print it. So I wouldn't use I will not do this. I will not assign it back to itself. I will simply just print it. So I will go data, okay, I want to select select the values, select the rows where the x values are divisible by 2. That kind of makes it more clear. So over here I have data and I will say I want to choose rows. So I will basically leave columns empty because I want all columns. I will say data and I'll use this $, which basically is like a short form for doing this, but it's much faster. Once again, we're always looking for short forms to do stuff. So data x, we're going to say modulo of 2 equals to 0, and I'm pretty sure this modulo is double. There we go. So alright, so then we will run this, and oh no, I think I have to put print in the statement. Another mistake. There we go. So essentially we've chosen the values where x is divisible by 2. How are we going to do this if we're using the pipe operator? So instead of using Boolean indexing, we can use a function called filter. So once again, print, I'll just do that outright. So perhaps before that I shall decide what filter. I shall write filter over here, and pretty much it's a function as well. Okay, not function as well, it's a function because that was not a function, that was just indexing. So filter takes basically, it takes, similar to the Boolean indexing, it takes a vector of a logical vector with the same length as the vector that you are basically trying to filter, and it will return where it is true and where it is false. So something very similar. So let's just say we are going to print and we're going to say, alright, let's use, okay, this is kind of misleading, using dpylr, and this is without using dpylr, and I will use the pipe operator and not the pipe operator to show the two different ways you can do it. So print filter without using the pipe operator, we will have to put the function, put the data as argument in. So we put data over here, and then we basically say, well, data x is going to be basically the same thing lah, 2 equals to 0. Alright, so what happens then is when we source this, exactly the same thing comes out, pretty much the same thing. And you might ask, all right, but I've already learned this. Why do I have to do this? Because sometimes this can get quite confusing. And it pretty much, the name says it all. Like, you don't really have to think much about what this does. It, as the name says, it filters and, you know, makes sense. So that's why we kind of do that. So again, I'll show you how to do it without using, with using the pipe operator. That's just going to be pipe, and then we're going to say filter, and then we're just going to put in our condition, which is data x is going to be divisible by 2, and presto, everything is the same. So there we go, we have learned how to use filter. Very neat. I don't honestly think this is not a real tiebreaker for me, because deal breaker for me, because I kind of like enjoy doing the standard Boolean indexing, but it might be something very useful for you, especially if you're a beginner. You don't want to use, you know, this kind of confuses you, which is first rows, columns, column rows, etc. Filter is pretty neat, solves the problem, and of course, if you're doing many operations, you can use the pipe to truncate, as we've discussed earlier. So there we go, that's for filter. So let's now that we've filtered or we've selected rows, let's select columns. So now we want to select columns by name, let's just say. So let's select columns by name. Let's say if we were using, so let's say we're using base R, we would have just said print data, and then we have done this, we could have done this as well, etc. So these two will be the same. Yep, so print data, this will also be the same. Yep, so, or if you want to select multiple columns, you could have chosen to use print data. I think this would work. Let me check. Nope, this would not work. So you would, if you wanted to select both, then we could have, okay, no, this wouldn't work for printing more than one. So I would have to say print data, and I have to index, for instance, I would say rows, all rows, and I have to index both columns, and that would have printed. I mean, this would print all because there's only 2 columns. If I add another column, I would have to say, I would have to define it lah. So I would define it as so from column 1 to column 2. There we go. In this case, if I only did column 1, there we go as well. So in order to use, now we're going to use a different function. We're going to use select. So select is kind of interesting. Basically, it's a function as well, select, and it takes the name of the column. So if you have the numbers of the column, it won't work. You probably are better off just using indexing, because if you want to get the columns by the number, as in the index, then you have to probably use indexing. But if you have the name of the column, this can be a real lifesaver in a sense. So let's just say we wanted to select the first 2 columns, which are, there are only 2 columns, but let's say we wanted to select the first 2 columns. We could say print select, and then we could go into, okay, so we create a vector and we add the name, so x and y. Goodness. All right, so print it. Oh, I'm so silly. Yeah, I forgot again to put the data in. So data over here. There we go. All right, so yeah, once again, not very careful over there. We're going to try with using the pipe tool. So we're going to say data, piping it into select, and then the exact same argument that we put into select. There we go. So essentially, you've learned how to use the select tool and the filter tool. These are basically the 2 tools that kind of substitute the base R tools. I've shown you how to use the base R tools, and they are in the previous videos. If you have any doubts, you can just go back and double check. And that's essentially what the base R tool, that's essentially what the select filter tools do. I think this video is getting a bit long. To keep it short and sweet, I will end it here. The next video will be looking at using the arrange, distinct, and sample n, so sample underscore n functions in dplyr to essentially do more things with data. And we'll also be doing a mini project where we'll be looking at how we can actually implement the tools and techniques that we've learned to actually make stuff, or not make stuff, but do stuff with our data and do stuff with our tools. So till then, keep doing stuff, making stuff, and I'll see you next time.